Hello all, my name is Amlan Samanta. Welcome to my YouTube channel. In this video, I will discuss again about autoencoder. In the last video of autoencoder, I had discussed how it works, how the architecture is about autoencoder and how information flow through the autoencoder network. In this lecture, I want to discuss more about some real world applications of autoencoder. In the last video, I also shared some examples of autoencoder, but I thought that will be not sufficient for tackling interviews because interviewers don't get convinced if you tell only one or two examples. That's why if you have some more information about more examples in real world scenarios, how it can be used, then it will be very easy for you to handle or tackle interviews. So let's start the class. Some more real world use cases of autoencoders. Number one, complexity elimination. So in autoencoder we had observed, we saw that the main function is the reducing of dimensionality. In the hidden layer, how it actually converting the original input data into some latent space representation. That is where dimensionality reduction is happening. So dimensionality reduction is happening in a manner, it is actually reducing the complexity of the input data. I am giving you one example, very easiest possible example. Suppose you are dealing with image data. Now in that image, suppose that images are very high resolution images, okay, and now you are passing those images in a network which is actually designed in an autoencoder manner. It is already a trained autoencoder network. Now when it will be actually working on that images, it will actually reduce the dimensionality of the images. For example, it can make it more simplified. Maybe it can reduce the resolution of the images, right? That also in that way also the images can be simplified and complexity can be reduced. So basically this is the use case where autoencoder actually reduces the complexity of the input data. For example, you can tell the interviewer that suppose I have one problem statement to classify one image as a cat or a dog, okay. So for autoencoder you don't need to supply with very high resolution text images, means you don't need to supply some 4K resolution image of your cat or dog, right. You just supply some thumbnail or some low resolution images because it is already trained to deal with this kind of low resolution images, right, because in the training you had already taught this network how to actually reconstruct the original data or reconstruct the actual image from the low resolution images, right. It is already trained. So it will actually apply that knowledge in the inference, right. So it will actually understand from the low resolution images also. It can do that because it is already trained network. So this you can just tell the interviewer that suppose I have a collection of very low resolution images. They are also you can apply autoencoder to classify it as a cat or dog, right. In our normal life also, for understanding or for classifying our own pet, we don't need to see some high resolution images, right. We can understand from the low resolution images also, right, because that are our pets in our house. I have somehow, suppose I had taken a photo and that photo was not taken in a high resolution or it is a not very good quality or HD quality, but still I can understand that yeah, this is my cat or dog, whatever. You may have pet as dog or cat, right. Okay, so this is first use case. Now coming back to the list where I have mentioned other three use cases. The second use case is clustering. Okay. Now you can ask me that clustering is an unsupervised machine learning task, right? Why autoencoder is actually playing a role in solving this task? Because see, autoencoder is a unsupervised machine learning algorithm. Because why? Because you are not actually providing any training data, you are not providing any levels with your examples, right? The network can learn from the data itself. It doesn't wait for any leveling or any supervision or any kind of human intervention. That is why it is an unsupervised machine learning approach. Then why you cannot use in clustering? Clustering is also the similar concept. Here the clusters are actually formed based on the data itself. It actually the classifier, not classifier, the model is actually learning from the data. It actually captures the relationships among the data points based on some similar properties, and then it clusters between different clusters or groups, right? Here also you can apply the same concept using autoencoder. For example, you can tell the interviewer that you have a collection of images, and you are just supposing that there may be some data of some unlabeled images, okay, unlabeled data. Now you want to classify your cluster into a group or level. How you can do that? You can simply go and just apply clustering concept, because autoencoder, what it is doing, it is actually taking the data, reduces its dimension, and then from the reduced or the compressed representation, can you tell me what is the name of that particular representation? I had already told you. If you know that, just push that information in the comment. Let me know if you are aware of that particular name of that particular representation. So in that representation, I will not mention that, I will wait for your comments in this video. In that representation, what happened? Actually, the network converted that original input data into some low dimensional representation, okay, and from that low dimensional representation, it is actually reconstructed back into its original input. Am I clear about this? Because see, the network is actually trying to restructure this particular low dimensional representation, and based on that operation, it is decoding and it is just reconstructing back to its input data. So in this manner, basically it learns how it can actually identify some new data points, right? Because for some new data points, whatever properties or whatever attributes it had discovered, or whatever patterns it had captured, or whatever trends it had captured from the data, it actually kept those knowledge as a weight of the neural network, right? The neural networks actually keeps its knowledge in their weights, right? So don't worry, I will discuss about this things in upcoming videos. I had already promised you that I will come up with some videos of neural network. In next playlist, I may actually create a new playlist of neural network where you can see some very important interview concepts, topics of neural network, and also I will discuss some formal neural network questions, okay? So don't worry, I will definitely share some videos with you. But for this particular topic, that is the autoencoders, I thought that I can just tell you the basic concepts. Based on that, you can understand the concepts of autoencoder. So in clustering, basically you do the clustering based on some similar properties. So autoencoder tries to get some similar properties by identifying its relationships of data, and also it actually labels those information. It can get that particular capability, right? So in this way, you can also apply for clustering. Fine, no issue. Now going to the third use case, anomaly detection. So you are well aware of anomaly detection in nowadays. It's a very matured problem statement where you are trying to detect some abnormal data points out of some huge amount of data. Okay, not necessarily huge amount of data, but you are actually capturing some abnormality or some dissimilar patterns. Okay, this is your major goal for achieving this objective, the anomaly detection. So here how autoencoder comes into the picture. So the interviewer may ask, can you tell me one real life example where you can detect anomaly using autoencoder? So here actually you are getting the opportunity to describe him or her that how autoencoder can be used for anomaly detection. See, whatever autoencoder actually converts its input data into some low dimensional representation, it actually understands some meaningful information from the data. So suppose your data set is having maybe 10 million or 20 million records. Okay, now you are training the autoencoder with those data by splitting the data into training data set, testing data set, validation data set, right? Testing you are actually evaluating your data. But in real life use cases, when you are actually just pushing some records, and then you are actually providing the task to your network to detect some anomaly, basically it actually reuses the knowledge it gained from the data set it actually viewed in the training phase, right? Based on that knowledge, it actually tries to understand that it is not a normal data point, because it had already discovered the normality of the data set by understanding different statistical properties, different distributions of the data, and different correlations of the features of the data, right, in the training phase. So what is a real life use case? Suppose in a manufacturing plant there are lots of sensors installed in the different machineries and different machine components. Okay, and those sensors are actually taking some natural data, for example temperature, pressure, speed of the machinery component, then the temperature, as I just told. So these kind of data are captured through the sensors and the PLCs. Okay, and this sensors and PLCs, they are actually doing this capturing operation all the day long. Okay, so these are real-time sensor data, and the manufacturer team is actually asking you that detect some abnormal or some other unwanted patterns in the data points using some machine learning or deep learning approach. So autoencoder you can apply here, right, to detect some anomalies in the data. Yeah, that may be time series data, because this is basically captured in a real time basis. Okay, so definitely for a particular feature on across a particular time length, definitely the next line of data will depend on the present values. So definitely they are time series data. Okay, so these three things, and finally the image compression. Okay, that is also very well known or very mature problem statement, because in previous decade, or not previous decade, in previous century, there had been lots of image compression algorithms which were actually applied. For example, can you tell me one important image compression algorithm? Because it's we use this particular term on a day-to-day basis. Okay, can I tell you? So this is called JPG. Okay, JPEG. Okay, JPEG is actually a compression algorithm by which you actually compress your images into some low dimensional images, because you are losing some information. Okay, and that's why it is also called lossy compression. Okay, so JPEG is actually an algorithm for compressing your images. So why actually image compression requires, you can ask me. Definitely image compression is required. For example, you want to share a lot of images in your computer over internet, and you want to just reduce the usage of your internet, some data, limited data. You are actually browsing internet over a limited internet connection, data connection, then definitely JPEG can actually come as a useful way, right? So these are the basic requirements why you should go for using JPEG. Okay, and image compression, definitely a very well-known problem statement, but autoencoder can be used for also that. Why? Because it actually does some dimensionality reduction process while actually processing any input data. No, so while it will actually capture some input image, image data as input, it will actually convert those input into some distorted version by reducing the dimension, and from the distorted images it actually tries to reconstruct to the original input. This is the major funda, right? It is, I have mentioned this fundamental concept several times for your clarity, for your memorization, so that you cannot forget this concept, and you can efficiently handle your upcoming data science or machine learning interviews, right? So autoencoder is not very much used for image compression, but you can definitely tell your interviewer that yeah, it can be used for image compression process. Okay, so that's 4 things that I actually talked about how autoencoder can be actually applied for these use cases. This was all about the real world use cases of autoencoder. If you find this useful, definitely like this video, share with your friends, and comments with your answers that I asked in the content in the class. I will wait for your answers, and in my next video I will discuss about the major interview questions of autoencoder, where you can learn how to deal with those questions very effectively, so that interviewer can get convinced, and they can definitely offer you the job, right? So till then, goodbye. Thank you for watching this video.